Hi, welcome to the double displacement reaction videos. We're going to start by looking at two examples for precipitate reactions. In this video, we are going to learn how to predict products, balance the equation. We're going to go over that and also how to write a complete ionic and net ionic equation. So for double displacement reactions, and we're going to begin with precipitate reactions, they involve switching cations and anions to form two new compounds. So the formula is AB plus CD. Those are our reactant molecules, forms AD and CB. Notice how C is written first, even though if you're looking at the order here, you think, oh, I should write B first. We put C first because that is a cation, and cations always go first. All right, with that being said, our first example problem, we have silver nitrate and potassium chromate, and we need to predict the products. So we know that the silver is going to get with the chromate and the potassium with the nitrate. And so these are the two products I have here. All I do when I switch is I switch the cations and anions. I'm going to use the charge to figure out the subscripts to balance it out, to balance out the charges, because remember the overall charge must be 0. So the silver is with the chromate, but I don't know how many silvers and chromates I need until I put the charge of silver, which is +1. Even though silver is a transition metal, it is a transition metal with a common charge, so its common charge is +1. And chromate, you can look that up on the polyatomic ion chart. It's one of our polyatomic ions. Okay, chromate has a -2 charge. Okay, so with that being said, if you look at this formula, you can see here with one silver and one chromate, the overall charge does not equal 0. So what do I need to do to get the charges to be 0? In this case, I'm going to need 2 silvers, and you can figure this out using the crisscross method. So take the charge, the number that's on the charge of the anion, and use that as a subscript for the cation. So you cross it that way. And then this would have a subscript of 1. Okay, so that's our first one. Our second one is we need to figure the same thing out for silver nitrate. Potassium nitrate. One thing I want to point out here for potassium nitrate, notice that when I did the switching, I just took the K and put it next to the NO3. I didn't write K2 because I don't know if I need that 2. Now I did keep the 3 in the nitrate because nitrate is a polyatomic. So the subscripts for polyatomics have to go with the polyatomic. All right, so if you look at nitrate here, its formula is NO3. So that 3 belongs with the nitrate. This stays together as a group. All right, so with that being said, now that I have that, what I need to do is use the charges to figure out. Potassium is in group 1, has a +1 charge. Nitrate, if I look at my polyatomic, has a -1 charge. These charges cancel out, so this is the correct formula. I don't need any subscripts. Now that I have that done, I need to balance the equation. So when I'm balancing the equation, now I need to figure out the coefficients that would balance out the atoms on both sides. So there's kind of two balancing I'm doing here. I use the charges to figure out the subscripts so I can balance out the charges, get the overall charge to be 0. So the charges are used for the subscripts, the little numbers. In the case of figuring out the coefficients for the balanced equations, that's when I'm doing my tally that you see here. Okay, so I have 1 silver, 1 nitrate. Some people would say, oh, there's 3 nitrates. Remember, that 3 belongs to nitrate. If there was more than 1 nitrate, it would be in parentheses with a number outside of it. So I only have 1 nitrate because it's not in parentheses. And that, again, applies for polyatomics. I have 2 potassiums, and I have 1 chromate. Again, polyatomics, this stays together. That 4 belongs to the polyatomic. That stays together as a group. If I had more than 1, I would be in parentheses. All right, for silver, I have 2 silvers. I have 1 chromate, I have 1 potassium, and 1 nitrate on this side. So now with that being said, I take a look and I see, oh, my potassiums aren't balanced and my silvers aren't balanced. I'll start with the silvers. If I want to balance them out, I have 1 on the reactant side, 2 on the product side. I'm going to put a coefficient of 2. And when I do that, that changes the number of silver to 2 and changes the number of nitrate to 2. Now I need to do the same thing for the potassium. I have 2 potassiums on the reactant side and 1 on the product side. So now I'm going to go to the product side and put a coefficient of 2 in front of potassium nitrate. 2 there, 2 there, it's balanced. Okay? So that's it being balanced. Now, The last thing I want to talk about is complete and ionic equations. So to figure that out, we need to go to our chart and figure out which of these is solid or aqueous. If you look on the chart here, we're going to start with silver nitrate. Silver is here in this column, so at the bottom, to the bottom of the column, and then I'm going to go over to nitrate, and I'm going to see where the two intersect, and where they intersect, it says aqueous, so I know that that's aqueous. So I'm going to put AQ next to it. Potassium chromate is my next one. So the chromate's actually not in here, so there's a little note here that says all chromates are solids except for ammonium, lithium, potassium, and sodium. Since I have potassium chromate, I know this is aqueous because it's one of the exceptions, so it's not a solid. Silver chromate, that's not one of the exceptions. So all chromates are solid, except with these exceptions, silver is not an exception, so that's solid. And then potassium nitrate, potassium, and then go over here for nitrate. See where they intersect, that's aqueous, so I know that that's aqueous. All right. So now to do the complete ionic equation, anything that is aqueous will be broken apart into its ions. That means it will be broken apart into its cations and anions, positive and negative charge pieces. So silver nitrate, it's aqueous. I'm going to break that apart into Ag plus and NO3 minus because it's aqueous. Now, the other thing I need to remember is if it has a coefficient in front of the molecule, that coefficient needs to come down with it as well. Because there's not just one silver nitrate breaking apart into these ions, it's two. So I'll get two silver ions and two nitrate ions. All right, potassium chromate, that's aqueous, that's also going to break apart. So that breaks apart into K plus and CrO4 2 minus. Now in the case of the potassium chromate, that subscript will come down as a coefficient as well. So the reason that this subscript comes down as a coefficient is because this is what potassium chromate looks like. Okay, it has two potassium ions and one chromate ion. When they dissolve in water, it breaks apart into all the pieces, all the ions break apart, right? So you're going to get two K plus ions and one chromate ion. To show that there are two K plus ions, you put a coefficient of 2. So the subscripts also come down as coefficients. Okay, not the subscript on the chromate because that's a polyatomic. That subscript stays with it. All right, that's the reactant side. Let's do the product side. So Ag2CrO4, silver chromate, it's a solid. So do I break it apart? No. If it's a solid, you're going to keep it as is. Oops, I forgot the 2, Ag2CrO4. And then finally, potassium nitrate, that's aqueous. So we're going to break it apart. And once again, we break it apart into its two ions. We're going to bring down that coefficient. All right, so the thing to remember is that subscripts for elements and coefficients for molecules come down as coefficients. Okay, so subscript for elements and coefficients for molecules. All right, now that we have this done, this is called our complete ionic equation. So I'm going to label this as CIE. Now we need to do the net ionic equation. To do the net ionic equation, what you do is anything that's an ion looks exactly the same on both sides, you're going to cross out. So if we take a look at silver, on the reactant side is Ag+, it's a silver ion. But on the product side, silver is a part of a molecule. This does not look exactly the same. I'm not crossing it out. Go to the nitrate, NO3 minus. It's an ion on the reactant side and on the product side, exactly the same. Cross that out. Potassium. It's an ion on both the reactant and the product side, looks exactly the same. Cross it out. And then chromate, it's an ion on the reactant side, but it's part of a molecule on the product side. You can't cross it out. It doesn't look exactly the same. And what's left over, I'm going to write what's left over, Ag plus CrO4 2 minus, and Ag2 CrO4. This is my net ionic equation. And that's solid, aqueous, aqueous. Okay, so that's that. Let's look at one last example, this time with using a transition metal. So the process is the same. I've switched my cations and anions, so copper went with phosphate, and then the sodium went with nitrate. Now we need to figure out the correct chemical formula, so the correct subscripts to get the charges to cancel out. The thing with a transition metal like copper that doesn't have a common charge, you don't know what the charge of this copper is. It could be +1, +2, +3, right? It will all depend on the copper that you start with. So in order to figure out the charge of the copper, you go to the reactant side. Note I put a question mark here because I don't know what that charge is. And I can figure that out by looking at the reactant formula, because this formula is known. It's CuNO3,3. I have 3 nitrates for 1 copper. So how does that help me? I know the charge of nitrate. If I look on my chart here, right, the polyatomic chart, it's -1. So if nitrate has a -1 charge and I've got 3 of them, that means on this side, the overall charge here is -3. I know that the charge of the molecule must be 0. So what must the charge of copper be? In order for the overall charge of the molecule to be 0, it's +3. Because +3 and -3 together will give me an overall charge of 0. Okay? So with that being said, this is copper +3. Okay, so now I look at this formula. This formula is also now correct because the +3 -3 charge, they cancel out. So copper phosphate, that's the formula. I don't need any subscripts here. And the same thing with sodium nitrate. The +1 -1 charges cancel out. I don't need any subscripts here. So in this case, this was pretty easy. Now what we need to do is we need to balance it. So I have 1 copper, 3 nitrates. I'm using the 3 outside the parentheses. That's the 3. 3 sodiums and 1 phosphate. 1 copper, 1 nitrate, 1 sodium, 1 phosphate. Now that I look at this, I say, oh, I have 3 nitrates on the reactant side and 1 on the product side, so I'm going to put a coefficient of 3 in front of sodium nitrate. I do that, change the number of nitrates and sodiums, and now everything is balanced. All right, now once we've done that, we need to go into the chart and figure out what's aqueous, what's solid. If you look in the chart here, this chart doesn't have copper 3, it has copper 2. But a lot of times they have the same solubility. So I'm just going to write down what the solubilities are, or if it's aqueous or solid, I should say. So copper nitrate is aqueous. Sodium phosphate is aqueous. Copper phosphate is solid, and sodium nitrate is aqueous. So I just use the solubility chart to figure that out like we did before. So then for my complete ionic equation, my next step is to get the complete ionic equation. Anything that is aqueous, I split apart into ions. So, copper nitrate is aqueous. I split it apart into Cu3+ and 3NO3. Remember, that 3 comes from the subscripts outside the parentheses. I have 3 nitrates. 3Na+, a phosphate. That's the reactant side done. On the product side, copper phosphate is a solid. It remains together, so I'm not going to split that into ions. And then the sodium nitrate splits. And again, the coefficient in front of the sodium nitrate becomes a coefficient in front of both the sodium and the nitrate. All right, that's now done. So now what I need to do is to make my net ionic equation, I need to cross out anything that's an ion on both sides. It has to look exactly the same on both sides. Copper 3+ on the reactant side, but no copper 3+ on the product side, so I can't cross it out. NO3- on both sides, crosses out. Na+, phosphate on one side, PO4 3-, but copper phosphate on the product side, so they're not exactly the same, so I can't cross them out. And what I have left here is my net ionic equation shown at the bottom. All right, so that's it for the precipitate reactions. This is what you'll be expected to do for your assessment. Hope you found this video helpful. Have a quality day. Well, the next video will be about acid-base.